Okay, welcome back to part 5 of lesson 18. So we have our direction, d super y. We have our step size, lambda equal to 6. Now we're ready to compute our next solution. So we're going to update our basis. So first let's compute. So what does this mean to update the basis? This means, so this is equivalent to saying that a non-basic variable becomes basic, a basic variable becomes non-basic. Now this is where all of the work that you all have been doing for the online assessment for lesson 17, all of that pain and suffering really will hopefully help you pay off to understand what exactly is going on. The non-basic variable becomes basic. What does this mean? This is the same thing as saying that a non-negativity constraint is no longer active, right? Because as soon as we start increasing in our example variable x, which was held at 0, as soon as we start increasing it, the non-negativity constraint x greater or equal to 0 is no longer active. So while we're on the edge, n-1 constraints are active. We're not at a basic solution while we're along that edge. And we're moving until a basic variable is 0 because it became non-basic. And now we're moving to a place where n constraints are active. You see? So the equality constraints are always active along this edge. That's what it meant for the equality constraints to be satisfied for any lambda. By adding to the non-basic variable, we increase it, and the non-basic suddenly becomes, which is associated with an active non-negativity constraint. That active non-negativity constraint becomes non-active. Then we move until a different non-negativity constraint for one of the basic variables becomes active. Let's see how that happens. x1 now is going to be equal to x0, which is 0, 0, 24, 24, 23. Note that the first two components here, this is x and y. These are both active constraints, or they are why these constraints are active. Plus 6, remember lambda was 6, times 1, 0, minus 4, minus 1, minus 3. And what happens here is that this x greater or equal to 0 is no longer going to be active. Okay? Be sure you understand this part. Pause the video, go back, just try to really understand that. And don't overthink it. I think I make a big deal out of this thing, and you might think, well, it just means the variable is not 0, it's positive. And that's absolutely right. Just understand how that corresponds to the definitions, okay? Don't overthink it, but definitely work with it so you understand what I'm saying. Okay, so if I just do the calculation, I just multiply each of these components by 6, and I add them to these other components, and I get 6, 0, 0, 18, and 5. Now, see what happens. These two components, so y greater or equal to 0 and s1 greater or equal to 0 are active. And so now my new basis, sorry, my cat just walked across everything. The new basis now is X, S2, and S3 are basic now. And my active non-negativity constraints correspond to the non-basic variables. So in other words, Y and S1 are non-basic. Okay. What we say the entering variable was the new basic variable. That's what we call the entering variable. And the leaving variable is the previous basic variable that is now non-basic. Okay, so putting this all together, we start off with a basic feasible solution, x0. We have a solution index. For every single non-basic variable, we're going to compute a simplex direction and its reduced cost. If there are no improving simplex directions, we stop, we're done. That's our sort of good terminating condition. We found optimality. Otherwise, we choose any of the improving simplex directions. We let xe be the entering variable. We have another terminating condition. If d greater or equal to 0, then we also stop. The linear program is unbounded. Otherwise, we choose the leaving variable xl by computing the maximum step size according to our mean ratio test, or computing those inequalities for the greater or equal to 0, that's the same thing. Then we update the solution and we can just continue. So even from here, we could continue. Okay, I'm going to stop here, but before I stop, I just want to note, we don't know how to do this. This is the last piece that we have to figure out. How do we find an initial EFS? We're not going to worry about that right away. We're going to give you forms which always have initial basic feasible solutions, because right now you should just practice this iteration, and that's what we're going to do next week starting on Monday. That's the end of lesson 18. You have now learned the simplex method. So please go and do some of the homework problems, which I will